So why is this hard? It's, of course, a very big problem to do automatic speech recognition, to recognize what the person has said, and then to translate it into another language. Every step along the way, it's very ambiguous. We never really know what the meaning of a word is until we have actually looked at the context in which it was spoken. For lectures, in addition, we have difficulties because we don't know where the periods belong in a sentence. When we speak, we don't say comma or period, but they have to be inserted automatically by the system. You see that our system produces automatic insertion of punctuation, and in so doing, it makes the text more readable and more understandable. And also our translation component needs to actually look at this because it needs to know where the sentences begin and where they end. Another problem is that the speaker will often produce disfluencies. We cough or we hesitate, we say and all of this, of course, shouldn't be translated. It should be translated into nicely readable text. So we have to filter all these disfluencies out first before we do the translation. Another problem that you see here is that people also in lectures use special technical terms. Special technical terms will vary a great deal depending on the lecture. And where do we get these technical terms from? We have automatic algorithms that look in the internet. It looks for different technical terms in the PowerPoint slides, and as well as in technical research papers and documents that pertain to this lecture in order to extract the right technical terms and to look up their translation for the other language. All of this happens automatically in the background so that the system automatically adapts itself to the individual lecture that it's having to process. There are lots of other problems. For example, what do we do with formulas in the lecture? Or what do we do with images? What do we do with emotion or drama in a lecture? All of this still presents continuous research problems that we're working on to make the readability and the output of it more usable and more useful to the user. An additional problem, of course, is to add new languages. Currently, we are supporting 5 languages, but as we go, we would like to, of course, go to many more languages. The world has in total 7,000 languages, and in order to go for 2, 3, or 4, or 5 languages to 7,000, we still need radically different approaches to make the process of building these systems much more convenient and less expensive than they are today. We use a lot of neural network techniques that offer lots of opportunities for becoming more adaptable and more expandable to multiple languages, but also to different tasks and dialects and so forth. And these are issues that we see here also. Another problem that you see here is that we have to be fast. The speech recognition has to come out as quickly as the speaker is speaking the words, and then also the translation shouldn't fall behind by several sentences. It should come out even while the person is speaking a sentence. Human interpreters are very good at doing this, and our systems therefore have to do what we call low latency. They have to produce translation sometimes before the end of the sentence has been spoken. So we have to make early decisions on how a word or a sentence should be translated, even though the sentence hasn't finished yet. So this is necessary in order to produce simultaneous interpretation quickly while the speaker in front is speaking. Otherwise, the output would fall behind, and the audience, after all, should be able to laugh about the same joke as the people who are understanding the language.